So Professor Rocco Zito, Head of Engineering at Flinders University. Professor Zito is a professor and head of engineering at Flinders University, and as a part of his leadership role, he manages numerous research projects and teaching programs at the undergrad and postgrad level. He is also head of civil engineering at Flinders, and his research interests include the use of global positioning system for transportation applications. His research work has mainly involved the use of sustainable technologies to improve the effectiveness of transport. He also has a background in the assessment and investigation of environmental impacts of various policy initiatives. Please join me in welcoming Prof. Zito.
Thanks, Ali. Just before I start, to make it clear, this will be in the exam, worth 10% of the assessment. That's how we usually start in these rooms. As Ali described, I am the head of engineering. My research background is in transport systems, sustainable transport systems. So I'm no expert in this, but they thought it was a good idea for me to present on some of Ali and Tom Vincent's research that we're doing here at Flinders in this green concrete and green cities space as well. So finding that hard to read. Really, byproducts as cement and sand replacement. We're doing a lot of that. Industrial waste. Did someone say circular economy? I put that in there because a few weeks ago, I was at the Australian Council of Engineering Deans. So there were 35 of us there teaching all the engineering students in the country. We had a presentation by Engineers Australia CEO, Romilly Madju, who got put on the federal government's circular economy task force. Things are going to happen. Lots of things are going to happen in this space. We probably all know that. But government, our associations and stuff, as engineers, as clients who use these building materials and stuff, sustainability, reducing greenhouse gas emissions, it's already important, but I think it's going to ramp up a lot. The other research that they're doing using nanomaterials, graphene and the like, 3D concrete printing. Ali hasn't included a tour of our facilities here, but we do have the state's only 3D concrete printer, and he's doing some interesting research there. Natural fibers to reinforce concrete, GFRP reinforcement instead of steel, and using recycled plastics as aggregate replacement. That's all. It's not my research at all. Absolutely, Ali and Tom are the key investigators in that. So in this one, they're using some hooly-dooly stuff, lithium stuff, to replace some cement, which is great. For me, the interesting thing about this one, so I'm a civil engineer, they're a civil engineer, we all deal with a lot of civil engineers, but the problem is multidisciplinary. So all of a sudden our Nanoscience Institute and all the mass spectrometry and electron microscopes that they've got have all of a sudden become pivotal to the research that Tom and Ali do. And you can see some of the pictures there reflect the kind of multidisciplinary approaches you get when you ask a university to do stuff. It's really easy to go down to our chem or physics labs and stuff and ask to borrow their equipment and the like. Martin's gone, but he's their business manager and can attest to that as well. A lot of work on using recycled aggregates in concrete as well. A lot of the testing work, I think throughout, I'm going to go through a whole bunch of these slides. These are individual projects and stuff. The upshot is there's a lot of potential. I'm speaking to the converted here. There's a lot of potential in these materials. The real problem is scale. Thank you, Kane. How do we get these at market scale? And I think William harped on a really important point about on the client side of things, you need to make it simple. You need to make it really easy. I want a carbon neutral building. Tell me what I have to use. We're not there yet. We're not at scale. We're not at the point where we can do that. Using a lot of work on waste glass, and we've heard a lot about that. But again, getting right into the molecules and the atoms and how they're joined and all that sort of stuff. If anyone's interested going in depth in that, Tom and Ali are here. Ask them, not me. I'll try and speed through these because it's me between you and lunch. Okay. Thanks, Ali. Any other university need a concrete guy? Anyway, natural fibres. This is an interesting one for me. Sugarcane, waste paper and stuff that we haven't really talked about and stuff. And again, it's all a matter of the applications and where they get used. 3D concrete printing, that's down in the labs, but we're not doing a tour, are we, Ali? Anyway. And again, using the recycled aggregates on that. We have commissioned it, and we're just starting the early phase of testing there. I think that picture there on the left is the first successful pour. It doesn't look anything like me or Alistair. He's still working on that. Some other projects, GFRP, nanomaterials and the like, mine tailings, we're doing all that sort of stuff. GFRP reinforcements for utility poles, really interesting for this state. We don't use wood for our electricity poles. We use reinforced concrete because we don't have that much wood here, but trying to use GFRP to extend that design life and again, get that whole of life. Kane, you mentioned the source material. That's one aspect where it comes from. That should be in the LCA analysis. Not sure why all these people are patting themselves on the back. But again, if you can extend the design life and stuff, that's another way of trying to reduce the whole of life emissions. And we're looking at that. Stoby poles, that's what we call them here in South Australia. What happens when you use GFRP in connections? Now, I think David mentioned about providing those guidelines to the structural engineers and stuff so they can use these alternative materials with confidence. Recycled plastic aggregates, an interesting one. So a company that was taking waste materials from the Flinders Hospital, I believe, and maybe even our campus, maybe, Tom, yeah, our main campus. So all that yellow bin plastics, they turn them into what I think they call them atoms. Those things on the left there, atoms. We put them in concrete, and I think the strength results were varied, but ductility was so depending on your application and what you need to do with it. FRP confinement, Zach, I think that's your PhD. Yep, working on that. So we've got some students looking at when we're looking at, again, extending the lifetime of especially old assets and what government department, what asset owner is not looking at sweating their assets now over the long term. So can we use natural fibers to replace the man-made carbon fibers, carbon resins to extend the life of some of those assets. Durability of FRP, we've got a saltwater sprayer thing and stuff, so we can do accelerated testing as well. Again, Ali, we didn't have a tour of our labs, but anyway, and the like. So that's typical stuff, typical equipment universities have. This is my slide now. I've only got a couple slides left. Is green concrete, are we time critical at the moment? So the association is green building materials, that's great, but today's all about green concrete. And if we open the blinds, right next door to us, we have South Australia's tech colleges are all going to, so we have a state government who has chosen to build their next 5 technical colleges out of mass timber. Okay, so here we have a client. So why did they choose? And you can see there all the columns, the flooring, the foundations are still concrete, but all the columns and the flooring and the like, all mass timber. It's only 2 stories. Okay, I heard today. I think timber is up to 5. Tuan, have we gone higher than 5 yet? 28 meters. There we go. We're nowhere near that and stuff. But it's interesting as a client, there was a product that they could easily specify, fit for purpose, but concrete wasn't part of that mix. Why? Is concrete losing that battle? We can put the blinds down now because it's terrible for a screen. So timber is already seen as greenhouse friendly and sustainable, the technical colleges, and there's probably, now that the state government has sown that seed, there's probably a lot more of this mass timber to happen. So what does that mean about concrete? And is it our role to try and give concrete those green credentials or not? Anything else? No, that was about it there. Collaborating with universities. I've been told, I know, it's not always the easiest thing. Okay. Who do you approach? Usually it's personal relationships and all that sort of stuff. And I hope a credit to Tuan and the team who do these roundtables across the country and try and make it a lot easier for industry, government and universities to work together. But typically, not only for Flinders, but most universities, hey, we do a lot of teaching, and here at Flinders, we've got 100 to 200 engineering students every year looking for research projects. That's across all disciplines. Remember, I talked about this multidisciplinary approach. Across all disciplines of engineering, we run 8 different disciplines of engineering here at Flinders. Tuan at Melbourne Uni can probably add another 0 to each of those across all the engineering programs. And that's at the undergraduate, masters and PhD levels. PhD students, we really crack the whip on them, and it still fathers me why industry aren't bashing down our doors. You can get one full-time equivalent employee for 35k a year, as long as they're working on a research project that's within your scope of field. Cheap labour, isn't it, Zach? Oh, this is being recorded, sorry, but everyone knows that. That postgraduate education and the like is in there. Our work integrated learning, all engineering degrees, we need some sort of work integrated learning, however that happens. At Flinders, one of the points of difference in our engineering programs that we're really proud of is that the undergraduates do it for 20 weeks, okay? So that means third year, second semester, for the whole of semester, they're out in industry doing stuff. When I first joined Flinders, I said, oh my God, that's 4 subjects they're missing out on, how they're supposed to get their advanced level knowledge and training and stuff. I came from UniSA, where they did the traditional 8 to 12 weeks over Christmas. And if you're a construction company, that's an absolute waste because not much happens. But now that the feedback that I'm getting from the students and from industry, that all of a sudden these students can do something useful. And especially if you're doing some R&D work that hasn't really got a direction or a focus, you can get some students in there and stuff. Again, it's a good way of doing that. Obviously, research grants and opportunities linking up with the universities does allow you to leverage lots of other federal and state monies, usually in the ratio of 1 is to 2 or 3 for industries. Plus, if your industries are making profit, and you probably wouldn't be here if you weren't, you should be eligible for the R&D tax incentives as well. So for businesses, again, it can almost be cost neutral and stuff. And why they're not bashing down our doors, I don't know. We'll have a chat over lunch. And a lot of the grant opportunities, there are lots and lots that you have to apply. It's a competitive applying for, but absolutely, there are other schemes that are in negotiation. Okay, so we have at the moment, Flinders has some manufacturing growth accelerators. Stuart's here, can tell you lots more about them and stuff. But if there's any kind of advanced manufacturing process that we need to apply to, whether it be green concrete or the reuse of electric vehicle batteries, one of my favorites, or anything like that, it's as long as the grants can be negotiated with and the Flinders panel, we can get some funding going there. Contract research, again, universities can be a consultant just like anyone else, fee for service type structure. But again, if it's the right project, that R&D incentive usually still applies. And what universities are famous for, industry skills development. Okay, we are educating the next generation of whether they be engineers, scientists, planners, whatever. But in this green concrete space, green building industry space, what do we need? Do we need a green concrete major in our civil engineering degree? Is that going to help us so our future designers can say that they have this major? And should it sit in civil or environmental engineering? Is that really what we need, or is it short courses for the designers that are out there at the moment so that they know how to use and source the appropriate references to build to the standard?